In this video, we're going to learn about two different types of solutions which differ based on their ability to conduct electricity. An example of a solution that does conduct electricity is salt water. This is because the solute in salt water, NaCl, is an ionic solute. Now, if we take a look at what happens to NaCl when we put it into water, remember that if we want NaCl, or any solute for that matter, to dissolve in water, we always need more water than salt. Now, when we put a solute in water, the water is going to form a series of attractive forces with the different ions within the solute. This is the subject of a different video. Now, we know that water is a liquid at room temperature, which means that the water molecules are constantly moving in seemingly random directions. If, however, all of the water molecules that have attracted to Na plus and Cl minus move in opposite directions like this, they can actually exert enough force to pull the two ions apart and get them to separate from each other. If these ions are now separated, that means that we can no longer see solid NaCl within our solvent, which effectively means that we have dissolved our solute. For this reason, if we have an ionic compound, the solution of that ionic compound is going to contain the separate ions that came from that ionic solid itself, hence why we call salt water an ionic solution. Now, because Na plus and Cl minus have charge, when we completely dissolve an ionic solute, that charge is going to distribute all around the solution like this, which allows an electrical current to pass through it, because electricity is based on the flow of electrons, and since we have a large amount of positive ions in the solution from the NaCl, those electrons will naturally migrate towards the positive charge, allowing an electrical current to form. For that reason, ionic solutions are also called electrolytes because of their ability to pass an electrical current through it. However, does every substance that dissolves in water form an ionic solution? Well, the obvious answer is no, and if you think about the second most common solution that we make in our day-to-day lives, sugar is probably what comes to mind. Now, sugar, if we take a look at the structure here, there is no obvious positive and negative side of sugar, which is because sugar is not an ionic compound at all. When sugar dissolves in water, it forms a type of solution that we call a molecular solution, because even though water is able to pull two sugar molecules apart from each other, water is not strong enough to be able to break sugar into separate ions, as what we saw with NaCl. For that reason, because there are no ions that are produced from the dissolving of sugar, these do not conduct electricity, and they are known by the rather technical term of non-electrolyte, because once again, there are no ions within the solution, and therefore no ability to pass electrical charge using the solute dissolved in the solvent. Now, both of these dissolving reactions are what we call dissociation reactions. Another word for dissociation effectively is the word separation. And if we write out the general formula of dissociation reactions, you can see why this is the case. If we consider the dissolving of NaCl, we know that our solute always begins in solid form, but when we put it into water, the two ions, the Na plus and the Cl minus, are going to separate from each other and exist as aqueous because they are dissolved in solution. So if we convert this into a general formula to show what every dissociation reaction looks like, we have AB, which is almost always going to be an ionic solid, and when we put AB into water, the A and the B, which we'll call A plus and B minus, separate into two different dissolved ions in solution. However, Dissociation reactions don't necessarily need to involve ionic solids. What about for solids that do not ionize? Well, if we consider the chemical formula for sugar, the technical name for which is glucose, we know that sugar starts in its solid form like this, but we do see the sugar disappear because the water molecules are able to pull individual sugar molecules apart from each other, just like with salt. When this happens, the sugar is no longer solid because we see it disappear, so we can, like with NaCl, write that the phase has become aqueous even if no ions have formed. In the next series of videos, we're going to look at the chemical properties of substances that allow some substances to be pulled apart by water, and we're also going to consider the properties of substances that do not dissolve in water and why they do not dissolve in water.